Have you ever faced peeling, blistering, or rough surface issues in your tiles, even when everything seems fine? The real problem might not be your glaze, it might be your own in-go behavior. This is Engineer Arshak Asfar. In this video today we will discuss coefficient of thermal expansion, hardness, softness of in-go in the ceramic tile manufacturing production plant. In this video, we are going to simplify one of the most misunderstood concepts in ceramic production, hardness and softness of ingot, and more importantly, what actually matters in real plant conditions. So what is a soft ingot? A soft ingot contains higher flux and melts earlier during firing. This means it starts flowing easily inside the kiln. This gives some clear advantages: better surface leveling, stronger bonding with glaze, fewer pinholes and surface defects. But too much softness can create serious problems as well: overmelting, blistering, even deformation of tiles. Now let's talk about hard ingot. A hard ingot resists melting and remains stable at higher temperatures. Advantages include maintained structure, better opacity, stable layer between body and glaze. But again, too much hardness can cause several problems as well, like poor adhesion, peeling or delamination, and rough surface defects in the tile production. So you are thinking, what is better, hard or soft? The answer is really simple: neither. Balance is everything. The ideal ingot should slightly soften, bond strongly, match thermal expansion, and still remains its structure. Here we will discuss the most important concept. Ingot is not just a layer, it is the main transition zone. It must synchronize with body vitrification process, glaze melting, and kiln firing curve. Now let's understand what actually happens inside a ceramic tile during firing. This diagram shows the complete interaction between the tile, ingot, and glaze, and why defects like peeling or cracking occurs. Now starting from the bottom, this is the tile body called ceramic substrate. It provides the main strength and structure of the tile. During the firing process, the body undergoes expansion and contraction, but at a relatively lower rate compared to the glaze. Above the body, we have the engobe layer, the most critical and often misunderstood layer. Engobe acts as a transition layer between the body and glaze. It provides or it improves the surface smoothness, color uniformity, adhesion or for glaze. And most importantly, it controls how stresses are transferred between layers. On the top, we have the glaze layer, the decorative and protective coating. It provides smooth finish, color and design, water resistance, and its durability to the tile. But glaze behaves very differently during firing. During heating and cooling, each layer expands and contracts at different rates. Glaze, higher thermal expansion, while the body possesses lower thermal expansion. This difference creates internal stresses inside the tile. These stresses are known as thermal stresses. If not properly controlled, they lead to cracking, which is also known as crazing, which can be identified by putting the tiles in the autoclave, laboratory equipment which is used to test the crazing in the tile surface. Peeling off, delamination. Now let's discuss the bonding mechanism. So how do these layers stay together? There are two main bonding mechanisms. The first one is mechanical interlocking, where the layers physically grip with each other. The second, chemical bonding, where the partial melting creates fusion between the layers. This happens mainly at the ingot interface. Why ingot balance matters? Now here's the most important point. Ingot must balance between body behavior and glaze behavior. If ingot is too hard, it cannot be bond properly, which can eventually cause us into the peeling problem. But if ingot is too soft, it overmelts. Defects like blistering or flowing will occur into the tile production. Now, that's why ingot is not just a layer. It is an engineering solution to manage thermal stress and bonding. A perfectly designed ingot ensures strong adhesion, controlled melting, stress compatibility, defect-free tiles. So next time when you see a defect, don't just blame the glaze. Look at the interaction between all three layers. Let's quickly understand the technical side. Fusion temperature relation. Higher silica and alumina content means higher melting temperature. Higher the flux, lower the melting temperature. Or in simple words, we can say more flux, it means the engobe will be softer, and less flux will means harder engobe. Now, in real production, as I have been working in ceramic industry, I will tell you that the too soft engobe will cause us blistering, flowing problems in the production, while too hard engobe will cause us peeling of glaze, roughness of the surface, and other problems in the production like blasting, etc. Balance engobe means smooth surface, strong bonding, and fewer defects. A good engobe is not defined by the hardness or softness. It is defined by how well it performs inside the entire firing system. So guys, tell me in the comments what issues are you facing in your plant. Is it peeling, blistering, or bonding issues? Let's solve them together. If you like this video, kindly like, comment, share, and subscribe my channel for more informative and real problems related to ceramic engineering for videos. Thank you.